محمد علی your microphone is open.
دکتر
بله برادر. محمد علی صدای شما رو دارم. محمد علی میتونید صحبت کنید.
بله دکتر جان، ببخشید معذرت میخوام. آخه یه خورده صدا قطع و وصل میشد، اون وقت لینک یه دفعه باز و
بله
بسته
بله.
شد، تازه باز شد.
اول کار همه قطع شدن یه دفعه. بله
خب.
بله. من در خدمت هستم. جان صحبت خاصی داری؟ محمد علی من خیلی دوست دارم که از کمکت استفاده بکنم که من بگم و شما ترجمه کنی برای بچه‌ها، اما خب ظاهرا اینترنت این اجازه رو بهمون نمیده.
وای قطع و وصل میشه دکتر.
بله 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 متوجهم.
جونم دکتر،
حالا دیگه
الان
به همون
صدا
روال
درست شد.
قبلمون میریم. خب صحبت خاصی داشتی؟ اوکی محمد علی، من به همون روال همیشه میرم جلو. متاسفانه میگم اینترنت اجازه نمیده که از توانایی شما تو ترجمه استفاده بکنیم. حالا جایی که گیر کردیم یا بچه‌ها سوال داشتن ازتون خواهش میکنیم که بهمون کمک کنیم. اوکی. Now it's time to talk about interconnection networks. Oops. What is an interconnection network? Till now, we talk about the parallel systems. Which are composed of several processing units. For example, P0, P1, P2, Pn. A parallel system contains several processing units. Simply, you can assume each processing unit is a simple Intel processor. But the interconnection network talk about the topology of the connectivity between these processors. مترجم کیست؟ محمد علی میکروفونش خرابه و اینترنتش خرابه، قطع و وصل میشه دوستان. نه مترجم نداریم متاسفانه. Okay. Interconnection network defines the connectivity between the nodes. Interconnection networks provide mechanism for data transfer. Okay. How do we connect the processing nodes together? For example, we can connect them in this style. We have several processors and I try to connect them in a ring style. بله برادر بهتر هست اما مترجم نیست. اگر کسی از دوستان باشه من خوشحال میشم، متاسفانه نداریم. Or we can arrange the processing units in a mesh style, like this figure, or in a new style called torus. Torus. In this style, as you see, the processing units are placed on a regular grid with wrap-around link. Wrap-around link. Okay, in this figure, you see three famous topology for interconnection networks: ring, mesh, and torus. Each node represents a processing unit. How we can compare these topologies together? Which topology is better or which worse? Can you hear me? I'm in the university, so my interconnection network is strong enough. Okay. Now, in this figure, in this slide, I try to define some metrics to compare interconnection networks together. We focus on topological properties of interconnection networks. We talk about just 6 different metrics related to topology of an interconnection network: node degree, regularity, symmetry, hop count, distance, and diameter. Yes, a node could be a standalone computer, could be an embedded computer, can be a mobile phone. Each medium that can compute could be a processing unit. Okay. In this slide and the next 2 slides, I'm going to talk about these 6 metrics. First, degree. What is the degree of a topology? Degree is the number of links connected to each node. For example, in this figure, this node has 2 links. Therefore, the degree of this node equals 2. For all other nodes of this figure, we can see that the degree is 2. Therefore, we say that the degree of this topology is 2. Degree of ring is 2. Why? Because all of its nodes has degree of 2. But for this figure, a mesh, could you say me about the degree of this node? Degree of this node, orange node. I call this D1. Okay, thank you, Nura. This node has 2 links. Therefore, its degree is 2. What about the degree of this node? Okay, 3. This node has 3 links. Therefore, we see D2 equals 3. And finally, what about the degree of this node? Thank you very much. Okay. D3 equals 4. As you see, in this topology, we have 3 different types of nodes. Some nodes have degree of 2, some degree of 3, and some of nodes have degree of 4. Very well. What about this topology? Could you say me about the D1, D2, and D3? Degree of this node, degree of this node, and degree of this node? I see your colleagues see the image. Great, Nazar, Asra, Muhammad. Thank you very much. All nodes have degree of 4. Why? Because all nodes have 4 links. And this figure and this nodes and this node all have 4 nodes. Okay, this is about node degree. What is about hop count? What is hop count? Hop count is the number of communication nodes traversed by the packet along the path between the source and destination. What this means? For example, assume that a packet must be traversed from node A to node B. Packet may be traversed this path 1, 2, 3, and 4. Therefore, hop count equal 4. Yes, that's right. محمد علی محمد علی میکروفون با شما هست، هر وقت صدا داشتیم
خوبین؟ صدا الان چطور شد دکتر جان؟ نه اینترنتتون خوبه، ولی اولی که لینک رو باز کردین یه خورده قطع و وصل میشد دکتر برای همه بچه‌ها.
آها الان درسته؟
آره الان درسته.
یعنی الان با خیال راحت بریم ترجمه کنی؟
آره صداتون
محمد علی یعنی الان میتونیم راحت من فارسی بگم شما ترجمه کنی میتونی؟ این محمد عبدالبناف داره کی رو قسم میده محمد علی؟
فکر کنم شما رو.
چه کارشون کردی مگه؟
نه والا، ولی خیلی از بچه‌ها اینجا گفتن که یعنی به فارسی و من واسه شون ترجمه کنم، ولی بعضی از بچه‌ها هستن که میگن نه فقط انگلیسی میخوایم.
دیگه والا سخته، من واقعا دیگه باید به یک قاعده همه چیز شیم دیگه.
والا دکتر یعنی من توی سازمانی فا و با دکتر آرش اینا همه یعنی باهاشون ترجمه میکنم، مشکلی ندارم.
دکتر آرش کدومه؟
دکتر آرش دلداری، سازمانی فا.
آها تدلاری من. آره. اوکی. بچه به احترام دوستانی که این سیستم آقای محمد علی رو ترجیح میدن، اجازه بدید یک مقداری با سیستم ایشون بریم جلو، چون بالاخره تا حالا که انگلیسی بوده یکم هم با سیستم ایشون میریم جلو. محمد علی به بچه‌ها پس لطفا اینو بگو.
يقول احنا نعتذر من الاخوان اللي يردون المحاضره بس انجليزي، فنستميحكم عذرا انه اكثر الاولاد والبنات ما جاي يفتهمون المحاضره بالانجليزي، فنقدر نواكب وياهم بالترجمه. شكرا جزيلا للجميع.
خب پس من الان چی رو گفتم؟ اومدم گفتم که از گره A به گره ایناشو انگلیسی میگم شما گیج نشید. از نود A به نود B میتونیم از مسیر بنفش بریم که هاپ کانتمون میشه 4. میتونیم از این مسیر بریم.
خب يقول نقدر من نود A الى نود B نتواصل بهذا الخط اللي هو راسمه بالبنفسجي، ماشي، يسموه هاب كاونت هاي العمليه. وجواها اكو المسير الثاني اذا تشوفوا باللون الوردي اللي هو سماه H2 اللي هو المسير مالته 5.
برای توپولوژی مش، برای رفتن از A به B مسیرهای
الوصول من A الى B عندنا هوايه عده مسارات.
برای مثال این مسیر با هاب کانت 4.
يقول مثال عندنا بالهاب كاونت 4 للوصول من هاي النقطة إلى نقطة B أو نوت.
یا این مسیر با هاب کانت باز هم 4.
أو المسير الثاني أيضا هم 4.
یا یک مسیر عجیب One, two, three, four, five, six با هاب کانت 6. محمد علی oops I think we miss محمد علی. الله اکبر. نور محمد. It's a terrible situation. We're actually exhausted. Okay. Sorry محمد علی. For the last topology, torus topology, we can traverse from A to B or send a packet from A to B from this path. From this path. What is hop count? But thank you Asra, thank you Noura, thank you Muhammad Ali. But we have another path using wrap around link. What is hop count? I have a major question. A smaller hop count is better or larger hop count? Muhammad Ali 9. Do you prefer a smaller or larger hop count? Okay, Zainab. Okay, Noura. A smaller is better. Why? Because with hop count of 2, we can send a packet faster to B, faster than the ping pass with hop count of 4. Okay, a smaller hop count results in faster data transfer. Yes, yes, yes. But for example, maybe this past be busy. Therefore, we just one choice. Use this pass to send the packets. Okay. In conclusion, we prefer a smaller available pass. Available pass with a smaller hop count. No problem. Any question? Yes, yes. It's a topic of it's an advanced topic called routing. We do not talk about routing in this course. When A wants to send a packet to B, first try the smaller path, the path with hop count of 4. If that path was busy, then try the alternative path with hop count of 5. Okay. The third metric called minimum hop count or distance. Oh, okay, Nazar. In routing, we have a topic called flow control. In this section, the busyness of the links are evaluated. Maybe by sending a dummy packet or any other method used in flow control. Okay. Now I want to compute the distance between A and B nodes. As you see, distance is the minimum hop count. Could you say to me about the distance between A and B in this figure? No? Yes. We have two paths. A path with hop count 4 and a path with hop count 5. Which one is the shortest path? Absolutely, the top path. Therefore, DAB for ring topology equals 4. For the next topology, could you say distance between A and B? This path 4, this path 4, and a path with 6, no shorter path, no shorter path. Therefore, the smaller path between A and B, just 4. And for the last topology, DAB, for torus topology. What is the distance between A and B in torus topology? Do you remember? No. No, 9. Yes, 2. Please note, a packet sent via this link to this node and via this link to this node. Just 2 nodes is required to send a packet from A to B. Therefore, the distance of torus topology is just 2 for the nodes A and B. Okay. Could you say to me about the distance metric? Which topology is better from the distance point of view? Ring, mesh, or torus? احسنتون رو احسن. Torus, because torus can make the shortest path for sending the packet. Now we're going to define the diameter. Thank you, Fatima Noor. حسین. Yes. More connection helps, but the topology is more important. More connection always do not means shorter path. Okay, Nazar? Thank you, Najla, Riyam, Hussein, Zohab, Zia, Maryam. Okay. Now, diameter. What is diameter? Maximum distance between any of two processing nodes in the network. It's a bit complicated. Please note, maximum distance between any two processing nodes, not just A and B. We are going to erase A and B from these figures. Any two nodes. Node 1, node 2, node 3, node 4, node 5, node 6, node 7, node 8, node 9. Okay? Any two processing nodes means 1 and 2. Distance between node 1 and node 2, distance between node 1 and 3, distance between node 1 and 4, distance between node 1 and 9. Moreover, distance between node 2 and 3, distance between 2 and 4, and so on. Distance between 8 and 9, this is the group of all distances. We must find the maximum number between these groups of group of numbers. Okay? Can you understand? Diameter or diameter is the maximum distance between any two processing nodes in the networks. Therefore, we should compute the distance between any two nodes and then find the maximum of them. Okay. In this figure, for example, if we want to find the distance between 1 and 9, could you say to me distance 1 and 9. What is the distance between 1 and 9? No, Nura, no, it's wrong. Yes. Distance between A and B is equal with distance between B and A. No. Just one. Just one. This is a wrong pass. This is correct. Just one hop, just one link is required to send a packet from 1 to 9 or from 9 to 1. Forget this long pass. A shorter pass is available. Okay, Fatima. How? I think this is clear. If you want to send a packet from 1 to 9, you use this link or you use these links. Obviously, you try to use this link. Okay. Please note, distance is the shortest path. Okay? In this part, we should first compute the distance between any two processing nodes. Distance is the shortest path. Therefore, distance between 1 and 9 is just 1. But in the next state, in the next level, we should find the maximum distance. Okay, first shortest path, then maximum distance. We do this to find the maximum available distance. The maximum time which is required to send a packet from a node to any random node. No. Nazar. Yes, short means 2, 3. The shorter is 2. 1 and 2. The shorter is 1. The smaller number. Okay. But what is the diameter for this network? What is the maximum distance? Visually, we see that. We can see that. for sending a packet from 1 to 5 or sending a packet from 1 to 6, we will face the greater distance. For example, distance between 1 and 5 equal 1, 2, 3, 4 pass for links. Therefore, the distance is 4. This is the maximum distance available in this topology. This is the maximum distance available in this topology. Therefore, we can say the diameter of the ring topology is 4. Diameter is the ring topology is 4. In your next homework, you should compute the diameter of mesh and torus. Nur Hassan, you can speak. The maximum distance, Nura, the maximum distance between all node pairs. Okay? Each pair of nodes. First, you should select all node pairs and then compute the distance for each pair, and finally find the maximum of the distance. Okay. Finding the diameter of mesh and torus is your homework. And finally, we are going to talk about the final two metrics, regularity and symmetry. Yes, mesh is 4. And also the torus is 4. Regularity. An interconnection network is regular if all communication nodes have same node degree. This is regular. Why? Because this node has degree of 2, this node has degree of 2, and in this topology has node degree of 2. Therefore, this topology is regular. Okay, no problem. Any question? Okay, what about the regularity of the mesh? Mesh is regular or irregular? No. Why regular? What is the degree of this node? 2. What is the degree of this node? 4. All communication nodes have the same node degree? No. A 1 with 2 and 1 with 4. Moreover, we have 1 with 3. Therefore, this topology is not regular. This is irregular. Okay? Can you hear me? Marve? Yes, this is irregular. Thank you, Mustafa. No sound? Can you hear me? One, two, three. 1, 2, 3. 1, 2, 3. Can you hear me? Najla? Okay, now yes. Mariam? Mariam, could you write in English? I cannot understand your words. Now, all students can hear me. No sound yet? Okay. Okay, it seems that the network is corrected now. For torus. Do you think torus is regular or irregular? Could you answer this question? Torus is regular or irregular? No, Naba. Torus is regular. Okay, thank you, Mustafa. Great. No, Noor. No fazad. Oh yes, Nura. Regular. Why? Because all nodes have same node degree. This node has node degree of 4. This node degree is 4, and so on. All nodes have same node degree. Okay. And the last metric is symmetry. Okay. Najla, Zariat, Mariam, Zia, Zohab, thank you for your answers. Oh, Rashab or Rosha? Sorry, what? I say that torus is regular because all nodes have same degree, which is 4. And the last metric, symmetry. An interconnection network is symmetric if all communication node poses the same view of the network. What it means? You assume that you sit as a person on this node and see the world from the point of view of this node. You see one node here and 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 here. You see 8 nodes connected regularly together. Now assume that you sit on this point and look at the network from this node, from the point of view of this node. What you see? You see 1, 2, 3, 4, 5, 6, 7, 8 nodes linearly connected together. Your position is not important. You may set on this position or you may set on this position. If you set on any of these nodes, you see one thing: 8 nodes linearly connected together. Therefore, we can say that all communication nodes poses the same view of the network. Therefore, this network have a symmetry property. Or this topology is symmetric. Zahra, you mean that my voice is choppy or my English is not fluent? We previously making a vote. Let's take that vote again. Which language do you prefer? English or Persian with translation? English, Persian with translation. Vote again, please. Okay, we are going to vote. Based on your vote, we decided to select one of these two options. Yes, Rosha. Wait a moment to taking this vote and then repeat your question. You are 54 students, more than 50 students, but just 28 students are contributed in this voting. Sorry, students, wait a minute. Okay, just 36 from 51. Okay, it seems that just 37 are present in the class. Okay. محمد حبلالمتین. Could you request the microphone?
سلام دکتر.
سلام. شما محمد علی شمایید؟ اینا حبلالمتینش رو گفتن من محمد علی نیکن من 2 تا مشکل دارم با ترجمه. یه مشکل من اینه که شما خیلی
میدونید چیه؟ مشکل از شماست به خدا. یعنی همه بچه‌هایی که داریم یعنی همه مشکل از پیش لینک، یعنی لینکی از شما اومده.
آره.
ولی بچه‌ها همه که الان میفرستن براشون میگن صدای همه داره قطع و وصل میشه.
آره نکن، چون من تو دانشگاه من برای کلاس آنلاینم خونه نمیرم، برای اینکه نزدیک دانشگاه باشم که مشکلی نباشه. اگر که قطع بشه من همون انگلیسی رو ادامه میدم، اگر نه که فارسی میدم. فقط به بچه‌ها اینو بگو لطفاً، الان اینایی که میگم رو ترجمه کن براشون. ما در رأی‌گیری قبلی قالب دوستان انگلیسی می‌خواستن.
قبل انه سوينا تصويت والاخوان اختاروا الانجليزي.
اما تو این رأی‌گیری الان ظاهراً نظر بچه‌ها عوض شده.
انه رأي الطلبة اكثريتها اختلفت، انه صارت ترجمة وباللغة الفارسية واحنا نترجم.
بنابراین منم سعی میکنم همینجور فارسی صحبت کنم، اما جا به جا جاهایی
مشکلی نیست دکتر. اگه یکی از بچه‌ها مثلا میتونن از انگلیسی به عربی هم بگن ترجمه کنن، منم مشکلی ندارم دکتر.
نه 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 اینجوری نمیشه، اینجوری نمیشه. همین کار میکنیم جاهایی که این بفرمایید، جاهایی که بچه‌ها سوال دارند و متوجه
شباب
نمیشن
يقول الاماكن اللي عندكم فيها مشكله او اي ملاحظه صادفتكم راسا قولوا لي اترجم لكم اياها فيها، فماكو مشكله.
اوکی
اوكي.
میخوام سفر رو به اشتراک بذارم که بتونیم کارمون رو انجام بدیم.
بله هستم دکتر.
محمد علی هستی شما؟
نه،
صفحه منو میبینید؟
فقط یه صفحه سیاه در اومده. شباب مو الصفحة اللي قدامكم سوداء مو هيك؟
فکر میکنم این امروز ادوبی کانکت یه مقداری اذیت میکنه. محمد علی
الدكتور راح
من یه میرم
يغادر
بیرون
ومن
میام
ثم
داخل
يرجع
ببینم
لكم
درست میشه.
على مود بلكة تصير هاي المشكلة تنحل.
محمد علی میکروفونتو وصل کن لطفا. اوکی. محمد علی من کلمه های تخصصی رو انگلیسی میگم، شما لطفا همونجور بگید. یعنی
باشه
مثلا
دكتور.
این که نوده میگم نود نمیگم گره، شما همون نود رو بگو.
اوكي
و
اوكي
سیمتری رو
يقول
میگم سیمتری.
اوكي شبابنا راح يعطيكم المفردات اللي هي العلمية خلينا نقول بالانجليزي. اوكي صايرين، بس الملاحظات وغيرها راح تكون بالفارسي على مود نوضحها.
اوکی. برای شبکه مش، برای توپولوژی مش، اگر من اینجا بنشینم از این طرف دو تا گره متصل میبینم، از این طرف هم دو تا گره متصل. محمد علی محمد علی محمد علی این تیکر رو ترجمه کردید؟ صدای من رو دارید بچه ها؟ Can you hear me? Thank you Ziyadin, thank you very much. I prefer to speak English due to these problems. من انگلیسی رو ترجیح میدم به خاطر این مشکلات. خب محمد علی هم بنده خدا اذیت میشه دیگه و وقتمون تلف میشه. Do you prefer Persian without translating or English? Unfortunately, the internet connection is weak. مریم چه کنیم به نظر شما؟ مریم ستار. Unfortunately, it seems that we cannot use the skill of Muhammad Ali in translating from Persian to Arabic. I think I have no choice but to switch to Nur Hassan. Nur Hassan. Yes, I sent a PPT. Oh, choppy voice, I cannot you hear. Noor. Yes, I send the PDF files. محمد علی برگشتی؟
بله دکتر، صدامو داری؟
بله صدات دارم، اما خب اینجوری نمیشه واقعا. حالا چه از سمت من چه از سمت شما باشه اینجوری نمیشه. لطفا آقای محمد علی به بچه‌ها این رو توضیح بدید، بگید که تلاش داریم میکنیم که فارسی با ترجمه بشه اما نمیشه. فکر کنم خود شما هم با این موافق باشید.
يقول احنا جاي نسعى للترجمة لكم وتوضيح للجميع، بس شوي هذا الصوت اللي يتأخر أو ينقطع على ساعة النت شوي جاي يأثر بينا.
دكتور when you
Sorry, very sorry, but it seems that we miss Muhammad Ali again. Okay. Therefore, I'm going to switch to English again. I'll try to respect your votes, but unfortunately, I don't have tool which is a translator here. Therefore, we switch to English again. Okay. We are going to talk about the symmetry properties of mesh topology. Okay. I say that if we sit here on this node, see two linearly connected nodes from this view and two linearly connected nodes in this view. But if I, for example, sit here, what can I see? From this view, and this view, two linearly connected. From this view, just one node, and from this view, just one node. Therefore, all communication nodes do not possess the same view. Each person sees a different view from the other persons. Okay, Asra. Therefore, this topology is not symmetric. This is asymmetric. Yeah, or this is not symmetric. Okay, no problem. Any question? Yes, yes. But what about the torus? For the first time, we sit in this position, and for the second time, we sit on this position. What is the things? See this person. From this link, two connected, two linearly connected. From this link, two linearly connected, and just this. This person, see two linearly connected nodes from each direction. What is the thing this person sees? From this side, two linearly connected nodes. Okay, and from this side, another two linearly connected nodes. Therefore, this person and this person both have a same view of the network. Therefore, this topology is symmetric. Any question? Okay. Now we define all topological properties or essential metrics for evaluating an interconnection network. First degree, next hop count and minimum hop count, distance and diameter, regularity and symmetry properties. Okay. Now I'm going to talk about a new concept, direct and indirect networks. Can you hear me? Can you hear me? Okay. direct network versus indirect network. In this course, we focus on direct network. But what is the differences between the direct and indirect network? In a direct network, each node in a topology of an interconnection network is both processing unit and switch. Indeed, each node is a PU and a switch. Terminal means PU or processing unit in this course. Okay, but in indirect networks, processing units are separated from switches. Processing units are separated from switches. Okay, as I said before, in this course, we focus on direct networks. What is the famous topologies for direct and indirect networks? For direct network, we have mesh, torus, k-array, n-cube, hypercube, and 3 topologies. And for indirect network, we have 3 factory and class topologies. In this course, we focus on mesh, torus, and hypercube in next few slides. Hussein, your microphone is open.
سلام دكتور.
سلام برادر.
ممكن محمد حبل المتين نتواصل عن طريقه؟
English or Persian I cannot understand.
نو انجليش بس عن طريق محمد حبل المتين خيكون بيني وبينك.
مايك محمد حبل المتين. تيك مايك محمد حبل المتين.
دكتور.
میخواید برای ترجمه میگید شما؟ اوکی. محمد علی لطفاً تایپ کنید دوستمون چی گفتن. Sorry, Hossein, I'm going to disable your microphone. Yes, Rosha, I will send the lecture in Darsa after the class. Okay, unfortunately, Muhammad Habl al-Matin is not present. No. Now. Okay. Okay. We are going to talk about mesh torus and hypercube topology in the next few slides. A mesh topology could be 1D, 2D, or 3D. A topology could be several dimensions. 1 dimension, 2 dimensions, and 3 dimensions. Okay. What means 1D? Just x-axis, 2D, x-axis, and y-axis, and in 3D we have x-axis, y-axis, and z-axis. This means 1D, 2D, and 3D. Okay, in 1D, as you see, the nodes are arranged in x-axis, in 2D, x and y, and in 3D, we added a third axis called z to our interconnection networks. What is the node, the number of nodes in this direction? K1 equals to 4. K, number of nodes in dimension 1. Sorry, wait. Sorry, guys. Okay. In this network, K1 is equal to 4, number of nodes in this direction, and K2 is equals to 4, the number of nodes in this direction. Number of all nodes is equal to K1 multiplied by K2. In this network, K1 4, K1 4, K2 4, and K3, the number of nodes in dimension 3, in direction of the z-axis, is 2. Therefore, overall number of nodes is equal to K1 multiplied by K2 and K3, 32, 16. Zohab, the formula mentioned by you is a special case. That formula is valid just when K1 and K2 and K3 have the same values. Okay, but what about the torus network? Torus interconnection. This is the mesh, this is the torus. Torus is not but just a mesh plus wrap around links. Torus is not but a mesh with wrap around links. This is the mesh 1D with wrap around links. This is a mesh 2D with wrap around links along the x-axis and wrap around links around the y-axis. This is the 2D torus. And also about 3D. For 3D, we just add another wrap around links along the z-axis. Wrap around links along the z-axis. Wrap around links in z, in y and x axis are available still. Okay. Therefore, we can say adding wrap around links helps the mesh interconnection network to be a symmetric interconnection network. This is the final results, adding wraparound links to make the mesh symmetric. Any question? A figure with more details are available here. Please note that a 1D torus is the ring topology. Ring topology is a special case of the torus network. When torus is 1D, the ring topology is created. Thank you, Marve and Mariam. And the final topology I'm going to talk about is Hypercube. Here you can see Hypercube from 0 dimension to 4 dimension. 0 dimension, 1 dimension, 2 dimension, 3 dimension, and 4 dimension. What is the name of this figure? Cube. This figure is cube. Okay. Sorry, Ziauddin, I cannot read your sentence. I think I should call you Muhammad Abdul Manaf. Okay. Okay. Hypercube is created. This is the node. This is a single node. We call this 0 dimension hypercube. Now, for creating 1 dimension, we add a copy of this node here and connect them together. A copy of this node is placed here and connect them together. To create a 2D, we place a copy of the 1D here and connect them together. Wow. Thank you, Muhammad Abdul Mohsen. پاینده باشی برادر. And what about 3D hypercube? We should add 2D in the base and add a copy of this on the top. And connect them together. And to create a 4D, we just repeat the 3D and then connect the nodes together. This is 4D Hypercube. In a Hypercube, K1 is equals to K2 and K3 and Kn if we have n dimension. For example, in this figure, in a 3D Hypercube, K1, K2 and K3 all are equal to 2. What is the number of nodes? Is 2 in power of number of dimensions. Okay, man. Okay. This is the end of interconnection network section. We will send you this table as homework. You should fill the entries of this table. For example, an n-dimension mesh, n-dimension torus, and n-dimension hypercube are symmetric or regular. What is their diameter? What is their degree? And what is the number of nodes? You can assume that Ki is the number of nodes in each dimension. K1 in dimension 1 x-axis, K2 in dimension 2 y-axis, and K3 in dimension 3 or z-axis, and so on for n dimension. Usually for more than 3 dimension, it is hard to have a visual representation. For more than 3 dimension, it's hard to have a visual representation. You could not draw a figure simply for high dimension. Okay. Now I'm going to talk about a new topic about decomposition. Yes. I will set the deadline on the Darsa website. On Darsa. Submit your assignment on Darsa, on the homework link. Okay. Next topic is decomposition. About 2 weeks. Okay. Till now, we just talk about parallel systems, which means that we have several processors for example, in this figure, 9 processors that connected together via an interconnection network. But there is a major question. How do we decompose a task? How can we decompose a task to parallel execute on the parallel systems? How decompose the task? How can we decompose a task to smaller parts, T1, T2, T3, T4, T5, and T6, and how map this task on these processors T1, T2, T5, T6, T3. Okay? In this section, I'm going to talk about decomposition. The methods exist to decompose a task to smaller parts and then executing each part on a processor of my parallel computer. Decomposition is the first step to develop a parallel algorithm. What is decomposition? Dividing a problem into smaller parts. What is the task? Task is our program. Task is your program that you want executing on a parallel computer. To show the dependency between the subtask, we require a new graph called task dependency graph. What it means? For example, we decompose the task to 6 tasks, 6 subtasks, and in first time step we execute task 1, task 2, and task 3. Then To execute task 4, we require the results of the first 3 tasks. To complete task 5, we require the results of task 3 and task 4. And to execute final task, task 6, we require the result of task 5 and task 1. This is task dependency graph. Which task requires the results of another task? In this figure, as we see, task 6 requires the output of task 5 and task 1. Any question? Yes, I'm going to upload this file after the class. Okay. The first example, dense matrix vector multiplication. Do you know about matrix vector multiplication? I'm going to express a introductory example. For example, we have a matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a matrix multiplied by a vector 1, 2, 3 is equal to, this is a 3 by 3 matrix, and this is a 3 by 1 matrix, a vector. Therefore, this will be a 3 by 1 vector. How we can compute this vector? We should multiply the first row of the matrix by the first column of the vector, element wise, and add them together. 1 by 1 plus 4 by 2 plus 7 by 3. In the next row, 2 by 1 plus 5 by 2 plus 8 by 3. And the last row, 3 by 1 plus 6 by 2 plus 9 by 3. 30, 36, 42. This is the results. This is an example how we can compute the multiplication of a matrix and a vector. Okay. Coming back to our example. We are going to compute the multiplication of matrix A by vector B to generate the vector Y. To compute the first element of the y, we should multiply the first row of the A by the B. To compute the second row, we should multiply the second row of the A by B. To compute the third row of the y, we should multiply the third row of the A by B, and so on. Interestingly, the computation of this element and this element and this element are independent. It means that to compute any of these outputs, we do not require to know the results of the previous tasks or other tasks. Therefore, we can decompose the whole task, which is multiplicating A by B, to n subtasks. Subtask 1 is just for computing y1, the first element, and is the multiplicating of the first row of the A by all members of the B. To compute the subtask 2, we require just the second row of the row A and the whole of B vector, and so on till the final task called task n. Oops. In task n, we just require the last row, which is n here, last row of A, and the whole B. To compute the last element of the y vector. This is the composition. I simply divided a great task, a big task, to n smaller subtasks. Any question? Okay. Okay, Muhammad. If you agree, I'm back to this slide to repeat the comments. Okay. We have a single processor. Oh, okay. Great, thank you. Next example. Database query. Do you know database query? What is database query? Okay, this is simple definition. You can use Wikipedia to understand the topic of database query. For example, in a database, we have such a table of various automobile: Civic, Corolla, Camry, Prius, Civic, Altima, Maxima, Accord, Civic, and Civic, with separate ID and production year and color and dealer, MNILNYCA or OR, and the price. Okay, in this table I'm looking for the car that are Civic. Okay. داده جستجو is a good synonym. Civic, model, year, production year 2001, and color, green or white. I'm looking for the Civic produced in 2001 with green or white color. Civic, (2001) green or blue. بله. Green or white, sorry. White, green, white, green. Just this row. Meet these limitations. Civic 2001 and why? Why no white? No problem, Mama Jafar. I'm going to repeat. You can simply assume database query is searching inside a table. To search inside this table, first we should find which rows correspond to civic car, then which rows corresponds to production year 2001, and which rows correspond to our favorite colors, white and green, and then combine the results together. Therefore, we can find a car with ID 673 is our search result. Okay. We have several, at least two methods for decomposition this query. The first method. First, searching for all civic cars, this ID, then search for all 2001 production, and then task 1, task 2, and then combine them together with AND operator, task 3. Next, we find the cars with white color and the cars with green color, task 4, task 5, and then combine them with an OR operator, task 6, and finally combine the all results with AND operator, task 7. What is task dependency graph? This is T1, T2, T4, T5, T6, T3, T7, and finally search results. This is task dependency graph of this type of decomposition. What do task 2? In task 2, we're looking for the car produced in 2001. Another method. First, we are looking for civic car, task 1. Next, for the car produced in 2001, task 2. Next, we are going to find the car with white color, task 3. Green color, task 4. Task 1, task 2, task 3, task 4. But we are going to combine them together in another form. First, combine task 3 and 2 with an OR operator. Task 5. Then combine this results with an AND operator, task 6, and finally combine with task 7 to produce the final result. Okay, one task to decomposition. Okay, we require some definition to continue the lesson, but it means that the time is over. We require a makeup session. یک جلسه جبرانی نیاز داریم. محمد علی اگر در دسترس هستی لطفاً اینو بنویس برای بچه‌ها، یا اگه کس دیگه میتونه ترجمه میکاپ سشن رو بنویسه. سید محمد شما اگه بتونی بنویسی خوبه. We require a makeup session next week. Okay? Can you understand? Good. At this time, Monday from next Monday at this hour, at the same hour. Next week, Monday at the same hour. Muhammad Jafar, this is the topic of the next session. We require this makeup session. To finalize this series of slides and going to open MP. Fortunately, all of you install MinGW successfully. Very thanks to Ziauddin. From next session, we are going to start using your installation. We are going to use programming and learn how to accelerate or program using parallel computing. Okay. I'm going to delete all ink in the presentation and add it to Darsa website. Okay. Muhammad Jafar, I already uploaded these slides on Darsa. In this section, the first section, you can download that. This session is adapted from this book or main book, Grammar Introduction to Parallel Computing. This is a great book. This is a great book. You can find all the figures and all the contents in this book. If you want to learn more, read this book. Know this figure? Hypercube. Or car, Civic. Okay. Have a nice day. خیلی ممنونم از وقتی که گذاشتید. باز هم برای این مشکلی که برای زبان کلاس هست ازتون عذرخواهی میکنم. البته خب واقعیت اینه که بالاخره دانشجوی بین الملل and international student should know foreign language. یا باید انگلیسی یا فارسی رو بدونید. حالا سعی میکنیم یه جوری شکست بسته جمع و جورش کنیم به هم کمک کنیم. خیلی عالی بچه‌ها. مراقب خودتون باشید. امیدوارم که به زودی این کلاس های غیر حضوری خاتمه پیدا بکنه و ببینمتون. ممنونم زهرا. مرسی محمد. خیلی متشکرم ازت. زحمت زیاد میکشی برای کلاس. بسیار متشکرم. I'm uploaded your homework on Darsa tonight or tomorrow. Goodbye.